Let's try one more example from cylindrical coordinate system. Now in this example, we want to evaluate triple integral of xyz. This is your function f, xyz dv, where E is the region bounded by this cylinder and the paraboloid and the xy plane. Okay. Let's draw this one. Let's draw the domain E. So this one is c equals 0. That's the lower boundary. Upper boundary is c equals to x squared plus y squared. C equals to x squared plus y squared, which is a circular paraboloid. Okay, so you should get this is your paraboloid. This is your paraboloid. Okay, this is your paraboloid, like this, and then we have a cylinder. Okay, let's draw the xy and z axis. It's the x-axis. This is the y-axis, and that's the z-axis. Okay, and now we have this cylinder. Radius of the cylinder is 1. Cylinder. Have the cylinder. Okay. Now your domain E is should be this part. That's your domain E. That's the region in between these two surfaces, the cylinder, paraboloid, and the plane, c equals 0. Okay, now let's express the paraboloid in terms of the cylindrical coordinates. Okay, so cylindrical coordinates, c equals to x squared plus y squared simply becomes c equals to r squared, and cylinder x squared plus y squared equals to r. That's the boundary. So this cylinder is r squared equals to 1, therefore r is 1. Okay. Now this triple integral, the given triple integral becomes this, and so we have triple integral. In cylindrical coordinate system, x is r cosine theta, y is r sine theta, z is z, and dv, volume element, equals to r dc dr d theta. That's the volume element. Now your c goes from the lower limit of c is 0. Now you have a volume element over here. Lower limit is the xy plane. The upper limit is given by the paraboloid, which is r squared, and then r goes from 0 to 1, and theta goes from 0 to 2 pi. And the reason is this: if we look from the top, again you will see a circle with radius 1, you will see a circle with radius 1, that's the domain. So this is your domain on the xy plane. This boundary is x squared plus y squared equals to 1. This r squared equals to 1, therefore r is 1. Okay. And r is the radial distance. The lower limit of r is 0, upper limit of r is 1, and finally your theta goes from 0 to 2 pi. Okay, let's simplify the integrand. I have one r term here, another r term here, and another r term here. So basically you have r cubed times sine theta cosine theta times c dc dr d theta. My first variable of integration is c. So if you integrate this c, you should get c squared over 2 dr d theta. Okay, then r cubed and sine theta cosine theta terms act as a constant. Apply the upper limit and then the lower limit. You get r squared to the power 2 over 2 minus 0 times the remaining part. dr d theta, dr d theta. R squared to the power 2 is r to the power 4 times this r to the power 3 is r to the power 7. So basically you have r to the power 7 times sine theta cosine theta all over 2 dr d theta. My next variable of integration is r. So you have one half is a constant, so we can pull out the constant 1/2. With respect to the r variable, sine theta times cosine theta is a constant. Then we have the integral of r to the power 7. Integral of r to the power 7 equals to r to the power 8 over 8. Lower limit is 0, upper limit is 1, theta. And if you apply the upper limit, you will get 1/8. The lower limit results 0. So basically you have the value of this part is 1 over 8, which is a constant. Let's pull out that constant from the integral sign. So you have 1/2 times 1 over 8 times the integral from 0 to 2 pi of sine theta cosine theta d theta. Now how do we integrate sine theta times cosine theta? Well, if you recall calculus 2, we have a trig identity for sine 2 theta. Sine 2 theta, this is the double angle identity. Sine 2 theta equals to 2 sine theta cosine theta. Therefore, instead of sine theta cosine theta, we can write sine 2 theta over 2. So basically we can express this integrand as sine 2 theta over 2, 1 over 16 times the integral from 0 to 2 pi of sine 2 theta over 2 d theta. Okay. So now this 1/2 is a constant, so let's take it out. And we have the last integral, and it corresponds to the integral of sine 2 theta. Integral of sine 2 theta equals to minus cosine 2 theta over 2. Lower limit of theta is 0, upper limit of theta is 2 pi, and in front of this we have 1 over 32. So basically have minus cosine 2 pi, 2 times 2 pi over 2 minus cosine 0 over 2. Cosine 4 pi is 0. Sorry, cosine 4 pi is 1. So you have negative 1 plus minus times minus becomes plus. Cosine 0 is 1 over 2. So basically your numerator equals to 0 because you have negative 1 plus 1, 0. Therefore, this entire quantity becomes 0.